Iteration is a programming construct in which we do the same thing multiple times, presumably with different values. In a flowchart, it looks like this. We enter the loop, we go around the loop some number of times, and eventually we exit the loop and go on with the rest of the program. So this part of the loop is called the test. It tells us whether to enter the loop or to skip the loop. The statement here is called the loop body. This is the work that's done inside the loop. C provides several different kinds of loops, and we'll talk first about the while loop, which is illustrated by this flowchart. So the syntax of the while statement is while, parentheses, expression, parentheses, statement. And what it means is we first evaluate the expression. And if the expression is true, then we execute this statement. That's the body of the loop. After the statement is executed, we go back and re-execute, re-evaluate the expression. As long as the expression is true, we stay inside this loop. Eventually the expression should become false, which means we exit the loop. Here's some examples. The top one is a simple one with the condition being A less than B. This is our test expression. So we evaluate this expression. If it's true, we execute this statement. So we're changing A each time we go around the loop. If we don't change A or B, then this will always evaluate to the same value. So we'll either never enter the loop or we'll be stuck in an infinite loop. Here's a little more complicated example. We're going to initialize x to be 0. We're going to test whether x is less than or equal to some limit. And then our statement is a compound statement. We want to do more than one thing in the body of the loop, so we encapsulate it in a compound statement so that it's syntactically correct. So inside the loop, we print the value of x and we add 5 to it. We go back to the top, test it again, print, add, go back and test. Eventually, since x is getting larger, it will be greater than limit and we will exit the loop. Notice when we write loops, we indent. We put the brace here, the closing brace, lined up with the while keyword, and we indent the part that's inside the loop body so that it's easy to read. It's easy to see that this work is inside this while loop. Now occasionally it's more convenient to test the condition after the loop body is executed. So we enter the loop by executing the statement once, and then we test the expression. If the expression is true, we go back and do it again. If it's false, we move on. In C, this is expressed by the do while statement. So do statement, while, parentheses, expression, parentheses, semicolon. We need the semicolon to terminate the statement. So we execute the statement first. We evaluate the expression. If true, we go back to step 1 and execute the statement again. So it's the same as a while loop, except the test has been moved from the top of the loop to the bottom of the loop. Here's an example. I've simply rewritten the while loop from the first example as a do while loop. We initialize x to 0. We presume, in this case, that limit is a number that's greater than or equal to 0. So we go ahead and print it the first time without checking the limit. We add 5 and then we check the limit for the first time. So there may be different execution here. If limit is a negative number, then the while loop will never be executed and no number will ever be printed. In the do while loop case, x will be printed at least once, no matter what. What if we are in the middle of the loop body and we realize that we want to exit the loop immediately instead of executing the rest of the loop body? C provides a statement called break to do that. And so here inside a loop, we reach a point, we've tested x is less than or equal to 0. If that's true, we don't want to do this divide here because if it's 0, we certainly don't want to divide by 0. So for this particular example, I've decided if we reach that condition, if it goes negative or 0, we're just going to stop accumulating the sum here. So the break statement exits the most closely nested loop. So because a loop body can have any statement, it might have loops inside it as well. So a break sort of goes to the end of the current loop and exits immediately without reevaluating the expression. This is occasionally useful, but I don't expect that you'll need it very often. And even more rare is the continue statement. Continue statement is when we get partially through the body, the loop body, and we decide we don't want to stop executing the loop, but we don't want to do whatever comes after this in the loop body either. So the continue statement allows us to go back to the test condition of a loop. In case of a while loop, that's at the top of the loop. In the case of a do while loop, it would be down at the bottom at the while condition. So continue stops executing the body, goes to wherever this test expression is, reevaluates, and decides whether or not to enter the loop. So this is a way to write the same loop that I had before. It prints multiples of 5, but it's kind of a silly way to do it because here we're incrementing x by 1 instead of by 5, and we're testing to see whether we should print it or not, and if we don't want to print it, we don't even just use a simple if statement, we decide to use continue to go back. So this is kind of a silly example, but it shows what happens when the continue statement is executed. We go to the top of the loop in this case.